Okay. Okay, Assalamualaikum and a very good day everybody. So we are from group 1. We're going to present about pigment. So my name is Nur Aisha and this is my group mate Kurba, Syamani, Yuki, Pepe and Priyamita Benu. So we're gonna talk about pigments for the surface coating industries, and I will talk about the industrial development of this material. So as we know, pigment from the prehistoric time is used of ochre, iron oxide as a current. So as we know, it is started from a billion years ago. We have things that colored dye, shirt, and so on. It uses botanical material to make pigment with colors, like iron purple colors that came from a murex snail. So as we can see, the prehistoric time used organic things to make a pigment. But now pigment are made experimentally. We can create pigment in lab, like Jashbat 1704. He is accidentally create Prussian blue in his lab, and it also Jean Baptiste 1828 they create blue French ultramarine that more finer than the junior ultramarine. So as we can see, the uh, synthetic one is better than the original one. So the use in the pigment industry has evolved from time to time. This is because the industrial is getting bigger and bigger time by time. So we knew that pigment can be synthesized in the lab. So I have prepared a video to you guys see how pigment are created in the lab. So as you can see, we not using so many chemical, and it was DIY in the lab. So later we crush the pigment. Then uh we will add egg yolk to color to make the pigment become to use the pigment. After adding the egg yolk, the pigment was ready to use. So as you can see, pigments are also a DIY in the lab. We can make the pigment in the lab, and not only from the organic matter. So that's all for me. So I will continue with the classification of pigment that will be presented by my friend.
Okay, so I'm Sharmani. So I'm going to present the classification of pigment. So there are two classifications, which is organic and inorganic. Organic usually, as you know, it is based on carbon chain or rings or both chain and rings. It usually will contain metallic elements such as aluminum, iron, mercury, or gold to stabilize the organic component. So these are the examples of the organic pigments, which is azo, polycyclic, anthraquinone dioxazine, thiocarbonium, quinophytolone. Quinophytolone. And then we have inorganic. Inorganic is chemical compound that is not based on carbon. So the metallic salt precipitate, it is a metallic salt precipitate solution. So for example, it is in white, black, special, or in color form. Next, next. So here I would like to explain a bit on the classification of organic pigments. So exopigments we have a lot, which is monoaxo, yellow and orange pigments, di these azo pigments, beta nasal pigments, nasal AS pigments, azo pigment lake, benzimidazolone pigments, diazo condensation pigments, metal complex pigments, and also isoindolinone and isoindoline pigments. So all these pigments actually have its own characteristics. So and also users. So I would like to give some information uh, about these examples of azo pigments. So monoazo yellow and orange pigments usually it's a printing ink used in printing ink, and it's also a solvent resistant. Usually we use this color to for wax crayon, um, for watercolor, and also pen ink. These azo pigments for uh, for dry light yellow are pink. It exhibits weak light and weather fasteners, especially it's used especially in industrial finishes. Beta nasal pigments used to color plastics, automotive finishes, automotive fibers, and also architectural paint. Nasal AS pigments is also same. It's usually the same as the beta nasal pigment, which is used to color pigments, automotive, and also architecture. Agropigment flakes they have sulfonate and sometimes carboxylate constituents. Benzimida- Benzimidazolate pigment is a good corrosion inhibitor. Uh, usually it's used in aeronautic industry and also optical sensing. These condensation pigments used it on polyester, nylon, and also cellulose triacetate. Metal complex pigments usually we use it for dyeing of nylon and protein fibers, paint, toners or photocopies, lasers, and also inkjet printers. Isoindolinol and isoindoline pigments exhibit excellent light fastness properties, offer good bead stability and chemical uniqueness, and suitable for many paints and coating applications. Okay, and then let's see for polycyclic pigments. Polycyclic pigments have uh, phytocyanin pigments. It usually contains sulfonic acid group used as direct dyes for paper and as reactive dyes for cotton. And then here's quinacridone pigments. It's to make high performance paints. Usually we use in automobile and industrial coating. And then we have cerulean and perinone pigments. DPP pigments used in inks, paints, and plastics. And then we have pure indigo pigments. It's actually organosulfur compound that is used to dye polyester fabric. And then we have anthracycline pigment under anthraquinone pigment. It's used for coloring paint, ink, plastic, fabric, cosmetic, and also food. And then we have flavantone pigment used in graphic painting, ink, and then we have Pyranthone pigments and also anthracene pigments, and its using is same as the above. And then there's diazine pigments, triaryl carbon pigments, and also phenolphthalein pigments. So next, okay. So this is the classification of inorganic pigments. So as you can see, there is inorganic pigments and also complex inorganic colors. So there's a difference here you can see. So for white, we have the pigments there, and then for inorganic pigments black, we have the pigments there, and then we have complex inorganic colors, or we call it a CIC black, and then we have CIC orange, CIC yellow. Here you can see the pigments right there. Next, and then we also have organic complex organic color, inorganic colored brown, complex inorganic colored gray, inorganic pigments blue. Usually it's blue is copper, and then complex inorganic colored blue, inorganic pigments green, complex inorganic colored green, and also complex inorganic colored pink. Next. So that's all for me. I'll pass it to my friend to continue the presentation.
Okay, so now I'll be presenting on the properties of pigments. So, okay, next slide. These are the properties of pigments which I will be going in detail. Next slide. Okay, the first properties of pigment is actually the color of pigment. So the color of pigment mainly depends on the chemical structure, and usually this chemical structure is determined by the absorption and the reflection of the wavelength that occurs on the surface of the pigment. So usually colored pigments, they absorb the wavelength. For example, black pigment, they absorb almost all the light. White pigment, they reflect virtually all the visible light falling on the surface. For fluorescent pigments, they are quite unique because fluorescent pigments can absorb light which is not visible to human eye. So they appear to emit more light than it's actually falling on them. So they appear more colorful and more bright. The next property is crystal structure. So usually pigment, it can be crystalline or non-crystalline. And if it's non-crystalline, it means it is amorphous. Crystalline, as we all know, it is arranged, the molecules are arranged uh, orderly. And for non-crystalline, the molecules are not, it's arranged randomly. So it is possible for pigments to have different crystalline forms. So it is known as polymorphism. The next property is light fastness. Light fastness describes the resistance of the pigment to fading when it is exposed to sunlight. So when light hits a painted surface or a coated surface, it will break or alter the chemical bonds of the pigment, which will cause bleaching. And also it will undergo a process called photodegradation. So this pigment that resists the light effect is known as light fast. So how do you measure light fast? Is by exposing a sample to a light source for a predefined period of time, and then you compare it to a non-exposed sample to see the effect of the light fastness on the pigment. The next, next slide, please. Okay, the next property is opacity or also hiding power. So basically, it is opacity hiding power is known as the property of the coating, which enable it to hide the surface over which it is applied. When you apply coating on a surface, the main purpose is to you want to block the surface. So opacity or hiding power is how much the coating managed to block the surface. So it is directly linked to the application of the coating as well as the thickness of the coating. If a white pigment is appeared on the coating, most of the time white pigment, they tend to reflect the wavelength. They don't absorb the wavelength. So it appears to be opaque, and also inorganic pigments usually have this characteristics. And for color pigments such as blue pigments, also black pigments, they will absorb this incident light at characteristic wavelength. So they are usually transparent, and most of the organic pigments have this characteristic. It is very common for us to use inorganic and organic pigment to get the best results. Okay, next is color strength. Color strength is the ability of the pigment to impart the color to other material. The higher the color strength, you need less pigment to achieve that shade of color. So usually color strength depends on the chemical structure and the particle size. So chemical structure, usually organic pigments, the color strength depends on the ability to absorb certain wavelength of light. For organic pigments, the color strength depends on the solubility of the solvent as well. Okay, and for inorganic pigments, they have higher color strength. And usually for inorganic pigment, if there's a cation trapped in their crystal structure, they have weak color strength. Particle size also plays a big role in color strength. The smaller the particle size, the stronger the color strength. So usually, for manufacturers, they prevent the growth of crystal during the synthesis to ensure the molecule is small so that the color strength is strong. Next, the last properties is heat resistance. A few pigments they degrade at temperature associated with the coatings. At high temperature, pigments become more soluble and shading will occur. So pigment with high crystalline structure, they're usually more resistant to heat. And the heat resistance basically depends on the modification of the crystal as well. For inorganic pigment, they have enhanced heat stability, but it's an exception to yellow iron oxide because yellow iron oxide it loses water when it is heated at high temperature. So only for yellow iron oxide, the heat resistance is not very good. So that's it for me for the properties. Next is Kurvashni for the raw material.
Okay, thank you, Priya. So I'll move on with raw materials that makes up pigments. Okay, usually your raw materials. Okay, usually pigments will be used as the raw material to produce compounds such as paint. So the raw materials that we are going to see after this, it's mostly can be seen like it's a common raw material that is used up to make paints too. Okay, so raw materials can be categorized into two as well as pigments because we have organic and inorganic pigments. So organic pigments, it's pigments that are derived from naturally occurring from earth, like naturally occurring carbon rings. So organic pigments are derived from aromatic hydrocarbons such as coal tars and petrochemicals. So in the case of petrochemicals means the chemicals that are used to manufacture pigments in an industry. So first is commodity petrochemical such as benzene, toluene, xylene, naphthalene, and ethylene. These are commodity petrochemicals which are furthermore processed to complex chemical intermediate. Okay, so complex chemical intermediate such as naphthalene sulfonic acid. Okay, so next up is inorganic pigments. Inorganic pigments are mostly will be used to produce by formulation to get desired products. So inorganic pigments can be derived from inorganic metallic compounds, mostly iron oxides. Mostly metal oxides. Most common metal oxide that are found iron oxides, and also salts such as chromates and sulfate. Okay, next. Next slide, please. Okay. Okay, so commodity petrochemical, as I've stated before, it's like benzene, toluene, and also all this aromaticity of xylene. Okay, inorganic metallic compound, iron oxide. Iron oxide can be used commonly because iron oxide has a common color and also it has an opaque and bright color such as salts too, like chromates and sulfates. Examples of salt I've stated here are lead chromate and potassium dichromate because it has a bright color and also an opaque color, which is a really appealing color, can be used to make pigments and also furthermore compounds. So iron oxides here can be used to produce ochre, ultramarine, and chromium green. All these are pigment compounds that will be furthermore used as raw materials to produce other compounds as well. For example, like cements also, and also pigments. Okay, so iron oxide here actually usually will be used in a iron oxide here will be used in a minimized way, which is 8% by weight. And also all these minerals, all these salts and inorganic metallic compounds, all these minerals will be introduced into a ball mill. A ball mill is an instrument used to grain and mix minerals together. And also the surface of this ball mill is made up of porcelain plates so that we can extract a very high quality pigments. That's all from me. Thank you.
So now I'm going to talk about the production of the pigments. Next slide. For the production of the pigment, we have two class. One is the organic pigments and inorganic pigments. And I will going to talk about the organic pigment. Organic pigment, we have natural organic pigment and synthesis organic pigments. So we now going to the next slide. Sorry, next slide. Yeah, for the natural organic pigments, as we know, the natural organic pigment is come from the natural source, such as animals or plant source. The example of the natural source are included the madder, indigo, and gambus and simprin. All these source is come from naturally from the animals and plant. For example, like the chlorophyll is like we extract from the plants to get the green pigments. And for the natural organic pigments, nowadays for the like industry or all the supplier is let's use the natural organic pigment because it's so hard to get the larger amount of the pigment. So normally they use the synthesis organic pigments or the inorganic pigments. So we are now going to talk about the synthesis organic pigment. Synthesis organic pigment are uh, the previous slide. Synthesis organic pigments are synthesized from the contact and petrochemicals. The example of the petrochemicals is phenolhalocyanide. Uh, the other synthetic organic pigments are made from the azotides and which contain the nitrogen compounds. Nitrogen compound, they are account for the most of the organic red, orange, and yellow pigments. The copper phthalocyanide provide the brilliant, strong, and blues, and also the green that color usually for the organic colors. And others, the pigments such as the fluorescence, and also is simply dye that have been produced by the chemical reaction. So we're now going to see the production, the process. One of the production of the azo pigments. Now is the flow process of the production of the azo pigments. First, we need to add the hydrochloric acid, water, and ice, and sodium nitrate is inside the diazotization vessel, and at the same time we also need to add the sodium hydroxide solution and water into the dissolution vessel. And also we going through the clarifying press and go both of the component will go into the coupling vessel. To coupling means like we need to pairing two items together. So after that we combine it and we go through the filter press, and after the filter press then uh, we we will dry it and mill it, then we will get the aqua pigments. So this is the one of the example of the production of the natural organic pigments. So now I am going to pass to my friends to explain about the inorganic pigments.
Okay, so I'm Yuki. I'll present about the production of inorganic pigments. So yeah, the raw materials that is from the inorganic pigments is actually will go through 7 process, which is filtration that remove the soluble impurities, and that go to gradings, cleanings, classification, and drying, and bleeding before the final product is packaging. Yeah, this is a general production of the inorganic pigments. So you can move to the next slide, please. Thank you. Okay, so here we would take an example to actually explain our production. The example we take is the titanium dioxide. For your information, the titanium dioxide is produced from either immanent rutile or titanium slag. So actually, there are two processes can produce the these pigments. So we will more focus on the sulfur process. Yeah. Yeah, okay. So the sulfur process employs simple technology than the chloride route and can use lower grade triple O's. However, it generally has higher production costs, and with the acid treatment is more expensive to build than chloride parts. Yeah. So the sulfur route is less environmentally friendly, but uh, the acid recycling and neutralization and combined with other byproduct developments can actually make it as clean as the correct routes. So uh, yeah, so the benefits of using the sulfur process is there is a simple technology and can use a lower grade and cheaper O's to actually get our pigments. Yeah, okay. Mm. So this is the process of the sulfur process to actually make the titanium dioxide, which is our example just now. So actually the titanium slag will go through the alkaline roasting and wash it, filtration it and leaching, solvent extraction and hydrolysis and filtration, wash it out, and then the last stage is the calcination, and then our pigment is produced. Yeah. Previous slide, thank you. Yeah. So I will discuss three main stage in the just now the sulfur route. Yeah. The first stage is the mix with sulfuric acid. Why we want to mix with sulfuric acid? It's actually want to remove remove the soluble impurities. Yeah, the titanium slag can dissolve in the sulfuric acid to form a mixture of sulfides. So any ions is removed from the solution. So we can get a pure O's, like the pure titanium. Yeah. So the color of the final product is not spoiled, will not destroy. Yeah. So the second main stage is hydrolysis. The titanium sulfide is then hydrolyzed in solution to give insoluble hydrate titanium dioxide. Yeah. So now the titanium dioxide is hydrate. So we want to go into the last stage, that is a calcination, is the drying process. The heating of the solid in a calciner is to evaporate the water and decompose the sulfuric acid in the dry solid. So at the last stage, we can get the dry solid of the pigments. Yeah. So this is the sulfur routes. Okay. So here is some application for the pigments that are we can use in fibers, leather, bleeding materials, paper, floor covering, ceramic, plastic, cosmetic, food, and others materials. So yeah, pigment can apply in every way we can see. Yeah, it's very useful. So can go to next slide. So yeah, in like summary out, in general, the same pigments are employed in oil and water-based pens, printing inks, and plastic. So yeah, in conclusion, the pigments may be inorganic or inorganic. The majority of the inorganic pigments are brighter and last longer than the organic ones. And organic pigments are made from the natural resources which have been used for centuries. Inorganic pigments are made by relatively simple chemical reaction. So here is some market research that reported by Technovia that we have taken here. So they find out the high stability of inorganic pigments color and high particle dispersion make the inorganic pigments is a popular choice for the manufacture of cosmetic products. So the industry research feel that the dispersion benefits of the inorganic pigments will push the industry growth and development of the worldwide inorganic pigment market in the incoming years. So this all from us. Yeah. Thank you for your listening.
Good.
Okay, so if you have any question, you can raise all your questions. So let us to answer you. So thank you.
Bye.
Bye bye.
Bye.
Bye.